All right, let's get started. Okay, new PRs in the last 2 weeks. I only saw two. It's possible I missed one though. The first is from Adam, and that's for this FIFO the data log, which I very much enjoy your comments, Adam. Don't never lose them. I don't actually know what this does. Adam, what's this PR do?
So we have been under the ruthless domination of OMAP for quite a while, um, and we've been trying to use less of it in RGW because I think we're probably the heaviest, biggest consumer, especially in things that are essentially linear. It doesn't really make sense to use a key value store to emulate a queue, and so this is basically just implementing a segmented queue on top of Rados objects.
Nice, very
We'll be
nice.
doing things like replacing the data log, the metadata log, and so forth with it.
That's great. Um, if it, ever in the future we had some kind of actual like native log in Rados, would be reasonably easy to like abstract this into that.
Yeah, should be.
Cool. Well, that's really exciting. That's really good news. I think in general, any kind of sequential logging we do in OMAP is a little crazy. Even our PG log stuff in the key value database is kind of nuts. So good job.
Yeah, the PG log was something that we had talked about, but it's more difficult to do in userland. Well, I guess our equivalent of userland.
Exactly. Yep. I hear you. I think once we start getting the opportunity to play around on the persistent memory devices, I'm hoping that will be the kickstart we need to really start looking at PG log. Maybe that's something we can also look at for user land from your perspective type stuff as well.
That would be pretty great.
Cool. That's exciting. I'm very curious to see what you guys see when once this stuff is actually in testable state. All right. Well, so the other big new PR, so I guess we have two big new PRs that are wonderful here, is Sam's initial C-store work. And Kifu has been reviewing that. I don't know what state it's in, but just having that there is a really big milestone. So really excited to see what we see with that work. So those were the only two new PRs that I noticed personally. Anything from anyone I missed? All right. Well, we had a bunch of stuff closed this week. There was a bug fix for the monitor to make sure that the priority cache manager invocation is also regularly calling balance and tune memory to make sure that we're properly releasing freed memory, and then also regularly rebalancing things as we should be. So that's good. That should improve the memory balancing and memory consumption of the monitor. Kifu had a PR that increased the standard deviation variance in the Crimson and classical OSD performance testing framework with Jenkins and CBT. So hopefully that will eliminate some false positive flags. Let's see. Oh, this one for increasing the 4K min alloc size on spinners from Igor merged. That was okay to merge now because of his other work merging with the hybrid allocator and also the deferred big writes PR. So that's really good. We'll hopefully get lots of testing in on all of that over the next couple of months in master. Majian Peng's PR. This doesn't actually change the OSD optimum threads per shard anymore. This one instead fixed a bug where we were not properly sending notification to all threads to wake up, I believe, if I remember right. That's what he changed. In any event, it improves performance when you have uh, like random read workloads. So that's really good. Um, Adam's sharding PR merged. So that's a big one that merged. I think we're still waiting on his tool to be able to convert OSDs from the old format to the new format. But having that PR there means now we can get a couple of other PRs that have been waiting uh, uh, implemented, including the double cache, no double cache PR fix, and also the age-based binning. And then we'll also have to change that tool for doing the OSD conversion, since the no double cache PR will cause an on-disk format change, just like the column family sharding one did. So hopefully we can roll all of that up then for Pacific. And the last one that merged is this one from Casey to use iterators for comparison operators and buffer list. We had a couple that were updated. Some discussion on my PR for the MDS to add a new expected files flag, or directory X adder rather. Just discussion with Jan about how to implement that, and kind of general feeling on if this is a good route to go or not. The Objection Triumphant had another review and I think another update in the last 2 weeks. I think Ilya
Yeah, I passed
reviewed that.
KRBD.
Oh, fantastic. Very good. Was that the last thing needed, Adam?
I think I need to do one more run of FS, but apart from that, yes.
Wow, fantastic. That's great. All right. Igor had a speed up removal by introducing collection list prefetch. That had been stale for a while, but it got reopened and rebased. I think it's ready for testing and review again. This Blue Store write lock. I think we're all a little scared of it. I think Majian Peng went through and figured out why it was failing in what I forget which tool it was, but there was a failure that I think he diagnosed and figured out. But I think we're all, well, at least personally, I'm still a little scared of it. Anytime we're messing around with the locks in Blue Store, it just makes me a little nervous. So I'm not sure how we proceed on this one exactly. I don't know. Maybe Igor's the right person to really dig in and make it okay. But in any event, we should probably proceed cautiously on this one. But if I remember, the performance looked really good. It was a nice improvement. So if it is safe, maybe it is worth doing. Okay, and then Igor's memory reduction PR for the O node. That one was rebased and it's now going through keep testing branch. So hopefully that gets merged. That's exciting. That's a nice reduction in the O node size. I think about 20% if I remember right. And also a little bit of a performance increase because of it. And that was it for the last 2 weeks from what I saw. Anyone have anything to add? All right. Well, the only thing on the discussion topics list for this week that I see is Niha wanted to present some performance experiments she's been doing in the Sepia lab. So Niha, do you want to take over?
Yeah, sure. It's more discussion than a presentation, but I just wanted to share some test results from some experiments I'd done. So the goal of this was to see how much variation exists in our SMIDI nodes, particularly if we run the same performance test on the same SMIDI machine over and over again. How much variation exists currently. Eventually, the goal will be that if we see there is acceptable amount of variation, we could potentially use these for some long-running performance tests using the existing Tautology CBT integration that we have. And yeah, I pasted some results in the chat. Hopefully everybody here can see it. But if it helps, I can share my screen too. Or Mark, do you want to go ahead? Do you want to go? I think everybody here should have access to the, whichever it works.
I see a couple people looking at it. Just 1 second, I can probably share. Yeah, clean up all the random windows I've got open on my desktop so it's not like overloading here. Just gotta log into the SSO. Okay, can folks see this?
Yes, we can. It's pretty small. If you can zoom, it'll be better.
Yeah, let me see if I can do that. Does that look better?
Yeah, yep, much better.
Okay, good deal.
So yeah, I guess what the two metrics that I've initially looked at was the IOPS and average client latency across 10 runs of librd FIO performance. And overall, in terms of IOPS, I am pretty satisfied. I think that the variation is not too high. As you can see, the average here was 5196, and most trials have similar numbers or acceptably close numbers. Latency, I still think there is a bit of variation, especially if you look at trial 9, comparatively high from the average value. There are a couple of other graphs. On the left, there is a plot of thanks to Sridhar and his visualization tool, we were able to plot the 95 to 99.99 percentile information that FIO collects. And as you can see, that variation also shows in the 99.99 percentile results of trial 9. As far as the last, yeah, go ahead.
I was just going to say, it looks like the 99.95 percentile is really close, though. Well, not really, but like much more close. That's good.
Yeah. And so Sridhar, what's the last one is just comparing all the this client latency and the latency, right? That's the metric. Is Sridhar on the call? I think so. But yeah, I think it's basically FIO collects client latency and latency, and this is just a comparison
That's
across all
that's
the
a
runs.
that's completion latency, Neha.
Yeah.
Almost,
Oh, it's
I'm guessing.
completion. Okay.
Yeah. So like submit latency,
Yeah,
completion latency, and then overall latency.
Yeah.
yeah. Sorry, I was muted. So yeah, the last graph essentially shows the average completion latency and the latency values compared across all the 10 runs. Yeah.
Yeah. So yeah, I think um, it's almost similar to the second plot that is there, but it is comparing both uh, completion and overall latency. So I guess it's not too bad in general. Also, I have to note that this is just one Smithy machine. I would like to spend more time on getting more data points across different machines and see if I see similar trends. And if the answer is yes, then we can go ahead and um, narrow down some machines that we want to use for this kind of testing. And we can probably do longer runs and other kind of things um, uh, once we are sure about our baselines. Mark, I would like to know your opinion as well. I mean, you are the person who looks at these numbers every day. So do these look acceptable to you? Is it worth pursuing?
Oh yeah, this looks great. I'm really glad to see that on an individual node, we're seeing. I mean, looking at this, the variation looks to me like it's well under 5%. If I'm just running it through my head properly. Yeah, this looks really good. I suspect that if you add the network in, we'd see a lot more variation, but that's, a future endeavor. Just doing single node, this isn't bad. Unfortunately, that's kind of the case where that's the easy case, right? Single node is where we can
Yeah.
get
Yeah.
good stuff like this. The
Mhm.
the benefit that Teuthology brings us is being able to do the big multi-node tests, and that's where we probably need to figure out how we're gonna
Yep.
do that effectively. But this is a good start.
Yeah. Yeah, I guess, yeah, that's from my perspective, I think I want to be very clear that at least single node uh, test results are worth looking at and reliable. And we like when we increase to multiple nodes, we know there are going to be other network and other kind of bottlenecks that will come in. But as long as we have this fine, then that's when we should start looking at the second step, I guess. So um, uh, I think I'm just going to do a few more experiments on some more machines, and then maybe talk to David Galloway about narrowing down some of these machines and do multi-node testing as well. At this point, it's a matter
Sure.
of I'm just like trying to lock Smithy machines and like run these tests over and over again. It's a pretty manual job at the moment, but if we want to do this on an automated basis, we'll want to do some sort of cron jobs or other things like that. But that's, I think, a question for later.
Neha, one question for you. This was a single OSD, right?
Yeah, no, these are three OSDs.
Oh, three OSDs. Okay.
Let me quickly share the profile, the workload profile as well.
Sure. While you're doing that, Neha,
Okay,
the reason
yeah.
the
Go
reason
ahead.
I asked about it was that the IOPS is around like 5,200, and these should be either Intel P3700 NVMe drives or Optane drives, depending on what which specific Smithy node we're talking about. The that number is quite a bit lower than what we can get with a single OSD. These are writes or are these reads?
These are just writes. This is at least I pasted the CBT
Oh, perfect.
configuration here.
Good deal. Okay. I see it. Okay, so 4K, random write, IOPS, IODEP 32, PG size 256, replication 3. Yeah, that's all just fine. So it's interesting to me that then we are seeing something on the order of about 15 to 16,000 write IOPS across the three OSDs, which is a little lower than we sometimes see. I'm curious about it. What? Sorry, was this master or was this? Yeah, it was master.
Yeah,
Okay.
it's just current master.
Are these all
Now,
on one drive, or are there separate drives?
I am guessing OneDrive. I didn't change anything much. I think it should be OneDrive.
Yeah, Josh, it's probably a single P3700 with four partitions, 4 virtual drives set up for the OSDs.
Sure.
It may be CPU limited. These things only have 4 cores in them, if I remember right. I think they're like 3 point something gigahertz with 4 cores. That might be the bottleneck. That might be the limitation. So if that's the case, then CPU is the thing probably holding these back.
Yeah, it looks
We
like you're right, Mark.
probably,
Only 8 cores in that box.
yeah, threads, I assume.
Yeah. Oh, that's Catbox CPU info. I guess is that threads?
Yeah, yep, exactly. So four real cores, 8 threads.
Yep.
Yeah, I suspect that we're probably CPU limited, which means that probably things like RocksDB compaction, the NVMe is probably fast enough to kind of absorb the extra I/O workload, but CPU will just we'll just have extra CPU overhead, which should slow it down. But that might change kind of the variance that we see in the results over time. Like it might be actually smoother because we're not seeing the disk backing up at all. I bet if we looked at the ClipDAL results, we'd see pretty consistent like IO depths on the device and queue wait times for the device.
I'm just curious, have we ever done any sort of baseline experiments on our Smithy or any kind of lab machines in the past?
Depends what you mean by baseline experiments. Do you mean
I know when the new Infernalis nodes came in, you did a bunch of testing on them.
Oh, sure.
Similarly, did we do anything for our Smithies ever?
Yes, I think we did when they first arrived, but it was really ad hoc, right? It was like verifying that they worked, and then that was kind of about it.
Yeah.
I don't think we did anything like wrote up like a formal report or anything.
Okay.
Would it be worth trying with just a single OSD on the box so that it would at least not be as CPU limited?
I think we will be in both cases, Josh, because I think even a single OSD will be able to saturate that really, really easily.
Okay.
Maybe not. It'd be interesting. What do you think, Neha?
Yeah, I mean, it's a big deal. It's worth experimenting and gathering results. Or I would actually technically try to do the same test one OSD versus three OSDs on the same Smithy box and see what the results look like.
I'm going to guess that you are going to see about 20 to like 25, between 20 and 25,000 write apps, given that CPU. That's going to be my prediction. We could do like a Price is Right style thing here. What do you think, Neha?
Sure.
I'll say 20 to be under a little bit.
Yeah, what's the prize money here?
Oh, I don't know.
You get a Smithy machine?
If coronavirus ever goes away, I'll buy you a beer.
Sure.
But how different are the Smithy machines when compared to Incerta nodes? Is there any
They
major
are
difference?
so the Incerta nodes have 20 physical cores, 10 cores per CPU, and they run at a lower clock speed. They're running at 2.3 gigahertz, I believe. They also have 4 P3700 NVMe drives in them, whereas the Smithy machines only have 1. And some of the Smithy machines, those drives have failed in, and I think they've been replaced by, in some cases, maybe by Optanes. So in terms of overall CPU, much less. But in terms of CPUs per NVMe drive, you might actually have a little bit more on Smithy, if I'm thinking about that right, because it would be basically on Incerta, it would be 5 2.3 gigahertz real physical cores per OSD, and on Smithy, it would be 4 real physical cores at 3.5 gigahertz. But I think Smithy, you actually get a little more.
That's from the tests I have run so far. So with one OSD on each of those drives, I was getting around 17 to 18,000 IOPS.
Really? Okay. Oh. Do you know if the what the TuneD profile was when you did that? We talked about this before, right?
Yeah. I think the profile I used was network latency profile.
Yeah. Okay.
But with balance,
Only 18.
interestingly, I was getting a bit more, close to 20.
Yeah. That's really interesting to me because on Incerta, I can actually pull off much bigger numbers than that with just a single OSD running on one of those P3700 drives. How much IO depth?
Yeah. 64.
Okay. That is interesting. If you can reproduce that, it'd be really interesting to run the OSD with one of either mine or Adam's wall clock profiler, and just take a look at that to find out which threads are really busy, and if there's anything different than what we typically see.
Yeah. I remember you did mention about this when I brought it up a while ago.
Okay.
But I didn't get around to do it so far. But I should try that.
I remember last summer when I was doing the cache work, I was doing a lot of testing on the OSDs, and I thought that we on Incerta had gotten up to about 35 to 40,000 4K random write IOPS with some of that work that was then merged. So if now we're seeing it, more like 18 or 19, we've introduced a regression. So yeah, we should look into that. That would be a good idea.
Yeah, I can pull up the numbers again to compare. Yeah.
Cool. Yeah, Neha, this looks good. I like it.
Ooh.
Yeah, and now that makes me really curious what you'll see if you do a one OSD test. So definitely, if you don't mind, that'd be great.
Yeah, I will share those results.
Cool. Is there anything in the second sheet? Should I open that?
Those you can go there. It's so that's some early experiments I had done across different smoothie machines, and this is I just saw the IOPS and I got discouraged, and I decided to just do on one smoothie
Okay.
machine. So I was just comparing. It's the same workload profile, but running on different smoothie machines, and I just looked at the IOPS. There's a lot
Okay.
of variance.
That's interesting. And do you know, did Toothology reboot all of these nodes before it ran the test?
Yes, it does. Yeah.
Okay, so that's actually pretty high variance, like about 10% almost, I think. Not quite 10, maybe like 8.
Yeah, I mean, whatever is worse than on a single machine, right? So there's, that's
Yeah,
also a part of the reason why I'm saying that I want to do the same kind of experiment on a different smoothie machine, to just see what those results look like. It's possible
yeah,
those might not be as impressive as the first one.
yeah. Smithy 068. That one looks like it's your worst one, so maybe that would be the one to try.
Yeah, I wonder if there's a way to just lock one,
Oh, no, so,
like, I mean, at least I don't know. Now, if you just lock a machine, you get a random smoothie machine, but I don't know if there's a way to say
You
that
can
I
lock one by
want
name.
to.
Yeah.
You can, right? Okay, I've
yeah.
never
Yep.
tried that.
Sorry, not 68, 78. That was the worst one. I missed it.
Yeah, 78.
Yeah.
So
Yeah, that's
thinking about this
interesting.
in terms of where we want to end up with CI, even if we do have some variation in machines, and if you are CPU limited, we can still get some valuable regression testing out of those machines, right? They can still tell us if there are more drastic changes.
Yeah, exactly, Josh. If we're looking at things like a 30 or 40% regression, then 7% or 8% variance doesn't necessarily change it, right?
Yeah. And in terms of being like CPU bound, um, what does that change? What does that not let us detect?
That would make it so that we would be less likely to detect things like increased write amplification in RocksDB causing slowdowns because the disk can't keep up. But if we were also recording the OSD log and running it through the RocksDB parsing script in the CPT tools directory, we could at least then go back and look at those and track whether or not we've seen a change in the statistics, even if we didn't see a change in performance.
That's a good point. Might be some things we want to analyze and extract the behavior from, even if they aren't reflected in the performance results due to other bottlenecks.
Yeah. So this thing right here, the Ceph RocksDB log parser, we can run that against the log when we create the log, and we could even just delete the log if they're too big to keep. But they shouldn't be for the performance tests, because we should be running at low log levels anyway. Oh, Neha, what log level are we running at in those tests?
That I have an answer. 0. Everything's 0. It's all optimized.
Oh, fantastic. So we will want to make sure that we get the RocksDB logs probably. It's really low overhead, so it shouldn't cause a lot of performance impact. But we should get that, and then we can run this thing against it, and this will give us all these statistics about like, you know, how many compaction events there were, what size they were, input and output records, all this stuff. So that's probably worth doing. And then if we're running against multiple machines, we may want to run this thing, which basically will take the output of two different systems sysctl dumps and then compare anything in the kernel that's different between them and give you that kind of a report as to what changed or what's different between them. That might be worth doing if we're seeing variance like you're seeing.
Okay.
Uh,
All you need is the OSD logs, right?
The OSD logs for that first one, that RocksDB like log parser tool, and then this thing, I think if I remember, it's been a while since I used it. It just will take the output of sysctl and you give it like two files, you know, one from, or maybe it's one or more files, and then it will take those output dumps and just it walks through them, looking at what's different between them, almost kind of like sort of like a diff, not exactly, but more or less.
Kifu, you had a question.
Yes, I'm not sure my mic works. Can you hear me?
Yeah,
Yes.
Okay, my question is I really want to understand the plan regarding to the Perfect CI, because I added it to the Perfect CI to our Jenkins. I don't want to, but as I mentioned last time, I think it's just a very beginning of our Perfect CI. I really want to know what our plan is.
So, Kifu, I think just my understanding is that the idea here is for Jenkins, we do tests looking at performance regression of specific PRs. Kind of the goal would be fast running tests. We iterate through lots of them, and hopefully we can test every single PR that comes in with a performance flag or label, and have different test suites that run based on the labels. So like RGW or you know,
So
or RVD or
what's the next step?
So I suppose the idea here then would be, do you remember? I think that Deepika added the ability to run the test based on the label, right?
As far I don't really know.
Okay, so I think we should verify that.
Deepika,
Go ahead.
Chiming.
I mentioned that I think that was the feature that was there in Jenkins, and you did it using GitHub books. So I think that is done. Josh reviewed it.
I think one of
Or
the next steps
CBT.
there was checking how we could run against disks. I believe we're currently the PI script is running against memstore.
Oh, yes. Kifu,
I'm not sure what kinds of hardware Jenkins is running on.
They're inserted
Kifu,
nodes, Josh.
Oh, okay, right. It's sort of.
Yep, we've got 4 of them right now dedicated for Jenkins, so hopefully that's enough to get us started. Kifu, would it be difficult to have those your tools run on a classical OSD on BlueStore rather than MemStore?
Oh, I see. So the next step is to run the CBT using BlueStore.
Yeah.
Okay. That's very straightforward. I just need to check it out.
I think another thing that came up in previous performance call was Mark, you suggested that we should have more realistic workloads that we should be testing against, and FIO was something that you wanted to include. So I guess
Yes,
it's a
we should do
question of
FI.
like currently we only have Rados Bench, so how hard would it be to hook up FIO with Jenkins?
I think it should just be a different CBT configuration file. I don't, and make sure that FIO is actually physically present on the nodes. Can anyone think of any reason that wouldn't be enough?
Kifu, what do you think?
Regarding to the more realistic load to send into the CBT-based test, that what I mean?
Yeah,
Yeah,
running FIO
Yeah.
instead of Rados Bench. Or
I
as
have
well, in addition.
I have no strong opinion regarding to this. I think it's if we can come up with more YAML file, I'm happy to add it to them. I just have no idea
Okay.
off my head what kind of overload we want to use to for exercising the one node cluster.
It'd be so there's it would be moderately long running, but kind of a four corners test, right? So with FIO we could do 4K, 128K, and 4 megabyte IO sizes across reads, writes, random writes, and then a mixed workload. And that would give us kind of a pretty good coverage for just kind of a generic FIO profile. Only question is how long to run each test for. I usually do about 5 minutes. So that would be about roughly an hour long probably for that test when you include setup and everything else. Is that too much, do you think, for each PR? Or is that reasonable? We could shorten the time length.
How many performance PRs do we have in a given day or week? It doesn't seem like there's like
Probably,
a ton.
yeah, but I think not that many, right? So we should be able to run that, I think, pretty well, unless we start doing it on every single PR coming in. I mean, I
Yeah, I
guess,
think it
Josh,
probably
we
makes
could
sense to start with just performance labeled ones, and if we wanted to test more, we could add the performance label to more PRs if you wanted.
yeah. Or Josh, I mean, we could also do something like, say, for FIO, we run it against anything labeled with either RBD or labeled with Rados. And then we're not testing like random like UI PRs or something.
Yeah. I think just getting it running against all the performance ones to start with is a good first step.
Okay. Yeah, that works. If that were the case, if that's what we're starting out with, I think we could easily run those tests for 5 minutes each, and that'd be like an hour-long performance suite for FIO, which wouldn't be too bad on one node.
That seems reasonable to me.
Cool. Yeah, I can just whip up a quick YAML snippet for the benchmark for one of the ones I typically use, and Kifu, I can give that to you if that would be the best way to go, or whatever. Oh, I see a new chat message. Yeah, I'm gonna stop
She's already
sharing
changed it
since I think
to
we're.
not use MemStore.
Oh, fantastic.
Mark, do you
Nice.
think it could be an issue using a file? Yeah, keeping notes in the chat instead of the block device?
Using a file for block device used by BlueStore.
It's running against
The,
vstart, so it's just the usual vstart setup.
yes.
Yeah, I see. I wonder a little bit. Well, I wonder a little bit if we should have CBT build the cluster instead of vstart. There are a couple of advantages to doing so. Then CBT knows uh, about the topology of the disks, so it can do things like run. Well, and it controls the OSD, so it can do things like start up with Valgrind or uh, do some other kind of block trace type stuff, which maybe we'd want to be able to add as a feature when you of a PR coming in and you see something weird. Maybe you want to be able to tell Jenkins, do it this way, run it with this thing added to the YAML to run something with CBT. Hmm. Kifu, what do you think are the advantages of using vstart to build a cluster?
I think the biggest advantage is that it's simple to use instead of using the Ceph.py, which is used by Topology, which is a little bit heavy weighted.
Oh, yeah, I don't even use that. I just use the CBT YAML to build it.
Yeah.
Well, for now, let's do this because it's already working. Josh, your question about using the file for block device. I'm trying to think what the ramifications would be there. It might have some impact on flushing behavior when you have like syncs happening. I'm not exactly sure what this would do differently, but it's probably going to have, you might have like an extra sync or something.
I think the pain of using Ceph ADM or using Ceph.py, which is used by Topology, is that they are all expecting a pre-built packages, which is missing in our CIs, and which takes a very long time to build the packages, right? So
Yeah,
I
let's
think
not
the
do that.
beauty of the CBT is that it does not need a pre-built packages, and it can consume a build directory which is built from source. That's the biggest advantage of using CBT or run CBT script.
Kifu, you can also have CBT build the cluster itself, and that also does not need packages. It can do it just with the source distribution. That's how I do it.
I think the pain is that the packages takes a long time to build, and I think that's why we choose to use the run -cbt or use CBT directly in our CI.
I can paste like an example file from Officinalis here. see. I see there's some chat window stuff happening here about packages. Okay, so this has lots of like commented stuff in it, but paste.centos.org there. All right, this isn't very cleaned up, but this is like an example YAML file for CBT from Officionals, just doing a single localhost OSD. So it's probably kind of a similar setup to what we do on if we wanted to use CBT to build the cluster, what we would do for Jenkins. The only thing we need here then is to have the partition labels set up properly for CBT to be able to know what to grab. But other than that, this is more or less what a CBT YAML file might look like for doing building the cluster itself, and then running. In this case, it would be like a single 4K random write FIO workload. There's lots of unnecessary stuff in here. You could shrink this way down, but in any event. Kifu, what do you think about something like this where CBT would be building the cluster? Are there advantages to doing it with vstart if it doesn't require packages or any different, if this still could be done without a source-based build?
We could do that. It's just need more tooling because our existing tooling are based on the assumption that we are using pre-built packages. For example,
no, this wouldn't require.
No.
Yeah, this wouldn't require pre-built packages. You can run everything out of user local bin.
Oh. Who's driving this script, or who is consuming this YAML file?
CBT.
CBT. Okay. Wow.
And then
never knew this.
And CBT then builds. Yeah, and CBT builds the cluster then.
So it's also able to partition the disks and set up the OSDs
the only thing it does not do is it doesn't partition the disks. It expects you to have partition labels for CPT already defined. So as long as you make the proper labels, then it should work okay.
Yeah, we could use that. We could pre-partition some test nodes, and so they can be consumed by cpt.py.
One advantage of doing it this way is that then if you see on line 39 in this case, it can optionally, you can have it run the OSDs with Valgrind just like on vstart. But CBT can also do this across multiple nodes. So you can actually build multi-node clusters this way.
Okay.
Maybe I'll see if I can go in on those nodes and partition the disks to allow CBT to do it, and we could just try it out on maybe just on one of them or something and see if it works.
George just mentioned over in the chat window that we have another. Probably we can pick another route by using a C start.
Yeah, this is longer term. So the idea of C-start is that you can use your local binaries with an existing container image and not need to build packages either. You just kind of replace the contents of the container with local development built packages, or not packages, sorry, binaries. And you can get up and running with the usual Ceph ADM tooling. So you kind of run a cluster just like a normal user would.
Nice, nice. Josh, if once that's ready, then one of the things kind of on the bucket list for CBT is to abstract away more of the Ceph cluster class, and we could make an implementation of that uses CStart instead of, and then also have the current one. But that would
we can
be
make an implementation
that'd
for
be really
CStart. We
nice.
can make an implementation for Ceph ADM itself. You just want to consume the existing images without having a local build even.
Yeah. How far along is that?
It needs a little bit more work. I haven't unfortunately had a lot of time to devote to it recently, but I'm hoping to get back to it sometime this month. It's a
Oh, sure, but
yeah,
maybe
it's a
by
work in
Pacific or
progress.
something though.
Yeah, hopefully by Pacific.
Okay, cool.
SH has kind of an initial implementation right now, but it still requires a bunch of copying of binaries around, so it's not quite ideal from a timing perspective. So the
Okay.
approach I'm pursuing is instead to kind of mount your build directory into the container and replace all the binaries with symlinks to your build directory essentially. So you don't need to do any data copying.
Josh, is there one of the things I've seen being really problematic in the past with containers is being able to run GDB inside of it? Is that something that we can build into this?
Yeah, I think as long as you allow give the container permission to with like the cap ptrace permission, I think that's what GDB requires to function.
Okay.
But I have also test it out and verify that works though.
Cool. Yeah.
I use GDB inside containers for Ceph debugging.
Fantastic. That's good to hear. Yeah, Josh, let me know how it goes. That would be really, really nice if we could build a separate cluster implementation using either Ceph ADM or CStart.
Yeah, absolutely.
Cool.
I'm really excited to get this working so that we can have the same experience for developers as we have for users, as we have for performance tests, as we have for correctness tests. So we don't have all these different methods of installing things everywhere.
Yeah, I hear you. The only reason why I actually was really happy about having it back in the day was because whenever like Ceph deploy back in the early days, was it Ceph deploy back then? Well, and even before Ceph deploy.
Make Cephfs. And you're thinking of
Make
that.
Cephfs, yes. Make Cephfs and then Ceph deploy, both of which would like periodically start failing. And so, having CBT do it itself was actually really nice because I could always, make that work or, try different things. And one method would usually install a cluster, but having a unified way to do it that consistently worked would be really nice.
Yeah, absolutely. Something better than the make Cephfs bash script back in the original days.
Yeah. Yep. That was what CBT originally used. All right, cool. We're like over time, guys. Anything else before we wrap up? All right. Well, hey, good meeting. Yeah, Josh, definitely let me know how it goes. I'd be interested in making use of that once you're ready.
Yeah, will do.
All right. Have a good week, guys.
Thanks, you too.
You too. See ya.
Yeah.
You
Yeah.
guys.